For the assignment for the k-means clustering, I've installed Cloudera VM with Jupyter Notebook, and I took the code from the tutorial. And to begin with, I have defined the Spark context, and then we can check the Spark context with SC. So the Spark context is defined, and similarly, I'm importing uh, k-means and k-means model from Pyspark and machine learning libraries. And I even imported NumPy, Math, and even Pyspark. And this is the basic Spark context and Spark conf which we need for Spark to run Spark. And after the basic imports, I am taking the iris dataset. So the iris dataset has these values where each of this is sepal length, sepal width, and so on for iris setosa, and there are three of these: iris setosa, versicolor, and virginica. But we'll not be using that. We'll only using the numerical values. So I'm taking this into a Spark RDD. So data is a Spark RDD. For that, I check the type. It's a Spark RDD. So Spark RDD is a basic data structure in Spark. So it's an immutable data structure. But we need to convert. We cannot operate on Spark RDD, so we convert that into an array, and then we work on top of that. So the another big advantage of Spark RDD is we can map it. We can use the map function of Python. So this map function would take each of the row, would take each of this row and then split with each value, that is with comma. We're splitting it with comma, and then we're making an array out of it. So we would get an output of all of this splitted in an array, and so on. So I'm just checking the type of it, and this is another type. This is not Spark. It's an RDD, but it's a pipeline RDD, which is like a subset of the RDD, and we cannot and this type it's not indexed, so we cannot use directly like park like 0 or something and then do. So we have to use another uh, function dot take, which just shows the first 5. And if you see, we have all the values splitted and in an array, and each of this value is unicode. It's not of type int or string or anything. So our next step would be to convert these values into a float, and ignore this part because for this say for k-means clustering we'll only be using numerical values. So if you look at that, it's unicoded. And similarly, we are taking we are using the map function again. We are taking this parse data one which we have splitted before, and then we are mapping only x of 0 1 2 3, that is only 5.1 3.5 1.1 0.2, and we're converting it into float and then making array out of it, and then we are mapping it. So this just maps each and every row. And if you look at the first 7, so we have got this as a numeric, and if you check at the type as well, it's float 64. Similarly, we have the error function. um, so k-means clustering clusters all the points together with a center, and then we try to find the mean square error from the center and the respective point. This gives us the efficiency. So this is a function error which takes in a point, and then the clusters is an object which we are training here. So k-means is the one which we imported from the library, and we're training it with all the params which we have, or the float values which we have of 100 iterations with randomly. And and as you see, I've printed clusters to see what is the type, and it's an object k-means model. And after that, we are passing these values each and every point to the error function, and in the error function we are predicting the clusters and then the center of that, and then we are using sum of squares. So here the point minus center would subtract from the respective point in the center, and then we square it, and then sum, and then square root. So it's a set of sum or squared errors, and later we are printing this. So let me just run this. So and we are printing it for 3 iterations as from the tutorial, and the sum of square errors is 1.105.358, and it's pretty much the same for second as well. And that's it for the Pyspark k-means clustering tutorial. Thank you.